My name is Ashraf Maliki, and I work as a senior researcher. Much of my research focuses on quantitative analysis of scientific publications, how they are cited, how they are circulated, how they gain influence, and I work extensively with all-metric indicators, which captures mentions of research including retracted publications across social media, news media, policy document, patents, and many other public platforms. What I want to achieve in this presentation is to deepen your understanding of how high-profile retraction case travels across the media landscape, how it is picked up, amplified, questioned, and eventually corrected. This talk concerns one of the most visible retraction cases in recent years, and more importantly, it demonstrates how retraction can continue shaping public understanding long after the underlying science has been withdrawn. This case will examine a study published in Nature in October 2020, room temperature superconductivity in a carbonaceous sulfur hydride. As shown in this slide, the author claimed that the superconductivity state, something normally requiring extreme cooling, has been observed at 15 degrees Celsius under extremely high pressure. This was an extraordinary claim. If true, it would have represented a historic scientific breakthrough with broad technological implications. However, soon after publication, concerns emerged. Issues with data transparency, replication failure, and methodological inconsistency was risen. These ultimately led to a formal retraction. Now, why this retraction is significant? Firstly, it is because of the unreliability of the data. The analysis, the raw measurements used to support the central claim couldn't be independently verified. Secondly, unreliability of the findings, which means that the published results did not survive scrutiny and ultimately distorted technological expectations about what might soon be possible. And third is the multiple concerns and notices issued over time, which signals instability around the credibility of the findings even before the formal retraction. These reasons reflect the deeper issues surrounding reproducibility, transparency, and credibility of the findings. Retraction reasons are not merely administrative. They reveal challenges in the research process itself. The most striking feature of this case is the scale of the online attention towards it. As the all-metric summary shows, the paper received thousands of mentions across X news outlets, blogs, YouTube, Wikipedia, and many more other platforms. So this slide shows the significance of the case from the aspect of online attention paid to it. In the donut on the right side, you can see there have been over 3,000 mentions across different platforms, and the most of them coming from X and then news outlets. We have 222 news outlet mentions to this paper, which drags a lot of attention to that. And this has been sustained over time. As you see, there has been a significant burst of attention right after the publication in 2020, and then it collapses, then it revives again around 2022 with around 20 mentions in both Twitter and news outlets and other media platforms. This shows a clear difference in media narrative and the changes in the scale of attention before and after retraction. We continue with the news outlets and the extent to which they have engaged with the publication. And as you see, there have been different ways they have framed their content over time. So the early 2020 and 2021 news were mostly focused on the breakthrough and discovery aspect of the retracted publication. Then in 2022 and mid-2023, when the retraction and the expressions of concerns come out, they are mostly focused on doubts and looming retraction. And later in 2023 and 2024, there are more mentions about the misconduct and a scandal around the retraction. There have been other types of reflections from the field, and some pieces mentioning that we don't have still room temperature superconductivity yet. And these have been like the most later reflections from the news. These phases illustrate how media framing evolves and how early hype often dominates public memory. Blogs and news outlets constructed a four-stage narrative: discovery, which is causing a rapid excitement around it; a retraction, which shows the factual updates; a scandal, which shows misconduct allocations; and reflections that discuss about scientific integrity. The hype, doubt, scandal, reflection cycle is common in high-profile scientific reporting. Understanding these patterns helps journalists avoid overstating preliminary findings. Social media sentiment analysis shows overwhelmingly positive reactions, especially in 2020. Users engage enthusiastically with the promises of technological breakthrough, but social platforms rarely highlight retraction, notice, or correction, meaning initial excitement continues circulating. This reveals how platform dynamics can preserve outdated narratives, particularly when corrections do not receive similar visibility. So the global spread of the discussion has also been wide. Engagement came from scientists, journalists, students, and the general public across multiple continents. This demonstrates that even highly technical research can rapidly become a global conversation. For journalists, this reinforces the importance of accurate, cautious reporting, because once a narrative spreads widely, it is difficult to correct. The paper also influenced patent literature, reflecting its impact on technological imagination, even though citations were from the same inventors group that authored the retracted publication. The use of a now retracted study in the patent application showed that scientific claim can influence innovation pathway before verification. This raises important question about premature technological expectation and the real-world influence of unverified research. Although retracted, the paper continues to accumulate even scholarly citations. This is typical. Retraction does not remove a paper from the literature. Tools like Cite.ai classify these citations as supporting, contrasting, or neutrally mentioning. The presence of contrasting citations shows critical engagement, but even critical citations help maintain the paper's visibility. This demonstrates how scientific ideas can persist long after their foundation have been invalidated. So we can draw several conclusions from this. The media did eventually report the retractions and investigations, but initial hype was far louder than any later corrections. Many early news stories remain online without updates, creating a long-term misinformation risk. Retractions alone do not correct public understanding. It requires consistent, responsible reporting, especially when new evidence shifts the scientific consensus. Finally, it is vital to recognize that not all retractions are the same. Some result from honest errors, statistical mistake, calibration issues, or reproducibility conditions. Others stem from misconduct, such as data manipulation or fabrication. This case primarily influenced technological expectation rather than causing direct societal harm, but it highlighted the difficulty of distinguishing between error and intentional falsification. For journalists, understanding this difference is essential. Both require transparency, but misconduct carries very different implications for trust, accountability, and credibility of the science. Developing the ability to report sensitively to this distinction is crucial for maintaining public confidence in scientific processes.